أتشرف الآن بدعوة الدكتور كلاوديو فوينتس جرونوالد من جامعة الملك عبدالله للعلوم والتقنية كاوست ليتحدث لنا عن برنامج تنمية التقنية الحيوية للطحالب في المملكة. It brings me pleasure to invite to the stage Dr. Claudio Fuentes Grunewald, Project Director, King Abdullah University of Science and Technology, KAUST. He'll be speaking about the development of Algal Biotechnology in KSA.
Thank you very much for the invitation. Thank you very much for MIWA to invite me to this excellent conference. So I would like to present. This is a project, this is funded by MIWA. It's a two-phase project. We are in the first phase, and I'm gonna show you what we wanted to do here in KSA. So first of all, why algal production and biotechnology in Saudi? Well, basically because aligned with the vision of 2030 strategic goals, the production of livestock and aquaculture feeds, food and nutritional supplement, and various products of industrial and pharmaceutical application. Why KSA is an ideal setting for optimum growth of seawater algae? Well, basically because we have really favorable conditions, especially environmental parameters such as good temperature for specific seawater strain, good quality seawater. We have a lot of irradiation. We have plenty of CO2 sources, no arable land, and seawater access, and one of the cheapest energy in the world. Also, there is research and development support through government academy industry partnership, as we are doing with KAUST, KAU as well. We have commercial partners like NACWA, SAVIC, and Aramco, and this whole environment allow us to move forward this technology in this country. Also, there is competitive advantage and favorable economic outlook for algal production and biotechnology. High economic multiplier effect through downstream engineering and supply, fertilizer producer, and upstream product development, export, etc. MIWA vision for sustainable aquaculture and fisheries in Saudi Arabia, I have to say there is a really clever way to do this. These are the three main projects that we are running now. So as you can see, the development of algal technology will support the new species in the project aquaculture development program. So we will provide in future the ingredients to include in feed for new species, and this will help us to the environment, to the stock assessment projects. Why? Because basically there will be a reduction in the pressure on stock assessment. So this is truly, I would say, a circular economy, circular ecology approach. So this is a really well-known graph, as you can see here. Basically, on your top left, we have the aquaculture projection by 2030. So definitely, aquaculture will dominate the production of seafood, and we will overcome, and currently we are overcoming the fisheries. And by that time, because of the goal of the kingdom is to produce nearly 600,000 tons of seafood by 2030, the idea is to use algae in order to produce the feed for these animals. So basically, what we're going to do, we're going to jump and we're going to try to avoid the first order consumer, and we're going to use the primary producer in order to support the production of intermediate predators or the standard fish that we eat on a daily basis. So why algal production for protein purpose? What I would like to say in this slide is basically that we cannot compete against soybean because of the price. That is for sure one of the key challenges that we need to overcome in algal biotechnology in future. And currently, the target is to produce 1 kilogram of dry biomass below $3 US, right? We cannot compete against soy protein, but what we can do, we can compete in terms of quality. So as you can see in this example, this is a work done by Montoya Martinez in 2018, and they use a freshwater shrimp, Macrobium tenellum, and basically you can see that the soybean meal, the content of protein is way lower than the spirulina meal, for instance. So there was 41% higher protein compared to the soybean. The highest relative protein digestibility was found in the spirulina meal, and the lowest one was found in the soybean meal. So basically, we can compete against soybean by producing a high-quality protein. As you can see here in the graph or in the table below, you can compare the amino acid profile of soybean and spirulina, and you see that the spirulina platensis have some essential amino acids that have better content compared with soybean. So I think that is the way to do it. Try to produce. We are producing an spirulina that we grow in brackish water, so it's not a freshwater strain, and we are currently successfully running in few hundred liters currently. So as my colleague Dr. Cross has said before, the use of microalgae in feed for fish is currently a reality. So basically, as you can see, we got a marine proteus, Taustochitrium, and basically these guys, they are producing oil, and big companies such as Biomar and Corvion, they are using Algal prime DHA in order to incorporate in feed for salmon. The problem that I can see now that this salmon is mainly for premium salmon, so for VIP people, I would say. So our goal here in KSA is to produce protein, but for all people, not for VIP people only. So that's the idea, produce protein to support local fish production and to get high quality food. What we're gonna do, we're gonna use the latest technology. We are bringing this technology from other countries. We are applying this technology here, and the idea is not to only transfer the technology. One of the key elements of our project is to transfer the knowledge. So we are currently working with Saudi staff. We're gonna bring a student. We're gonna incorporate Saudi people in order to learn how to grow algae. We're gonna use this type of system in order to produce oil strain. So basically, we're gonna use closed system. There is a high investment cost, but we can control nearly all parameters. So it is a pure culture, and we can produce in a daily basis high quality EPA or DHA. In order to produce the protein, we're going to use open systems like these examples in Indonesia and in Hawaii. We're going to use large open ponds or raceway. This type of system, they are really low cost in terms of investment. The problem, we cannot control environmental conditions, but we truly believe that this will be really successful in this country because the amount of light and the amount of CO2 that we have, we will provide us the good platform in order to produce the algae. Of course, we're going to use macroalgae as well. We're going to use seaweed in order to incorporate carbohydrate fraction, starch into the feed. There were some work done by NACWA a few years ago where they used ulva in order to bioremediate their effluent, but also to incorporate those one into feed for shrimp. So what are the technology that we're going to use? Long-line seaweed cultivation, for instance, pond for seaweed cultivation, raceway dam for seaweed cultivation as well. So the idea will be a hybrid system where we can combine bioremediation, and we also can use this biomass in order to be incorporated into feed for fish. So in order to do that, what we have been starting to do is to mapping all the carbon, nitrogen, and phosphorus sources and the facility that we can implement in KSA. As you can see, in the Red Sea, we have spotted several places, and there is more than 100,000 hectares area available in KSA in order to implement all these microalgae plant facilities. So this, we hope, inshallah, will look our production plan. So as you can see, this is one example. We have plenty of thermal power plant, and we're going to use the chimney, the CO2, in order to uptake the carbon, which is one of the main nutrients for us, in order to produce this algae. Also, we can, in the Red Sea coast, with good quality seawater, as this was highlighted before, and a top-of-range logistic, good infrastructure, good ports, airports, and motorways, which is fundamental for the production of this biomass. Probably you saw this slide before, but what we need to let them know to everyone that we need the help of everyone. We need all the stakeholders from the KSA in order to move forward this project. We cannot do this alone. We need a strategic partner like Saudi Agricultural Society, Aramco, SABIC, electrical company. There is a lot of knowledge in this country about refinery, about desalination plant, about plastic, and this is a key element for us in order to make this project works, because basically the key is to produce at lower cost, and by using the knowledge of these companies, we are going to be able to reduce the capex and of course the opex. Also, we have in our consortium, of course, MIWA and other universities and private entities like NACWA. This, what we think, and our projection, what would be the future role of algae industry in feed for animal in Saudi Arabia by 2030. So as you can see, in 2022, in our worst case scenario, we should be able to produce 1.8 tons of biomass. In our small demonstration plant that we are currently building, we want to start the operation by mid-March. And basically, if we do the projection, by 2028, we're going to be able to surplus the whole production of or importation of several raw material as barley, gold, corn, soybeans. So the idea by 2030 is not to rely on abroad for raw material for feed production and to produce locally, and why not to think to be an exporter of this raw material. So, of course, there is challenge. There are several challenges, we know that, and we have identified biological and environmental challenge. Of course, temperatures is one of the challenges, especially in inland, and especially during the hottest season. We will deal with evaporation as well, with the salinity, increases the salinity, sandstorm, and believe it or not, heavy localized rain as well. We have in KAUST a few weeks ago a massive rain that collapsed everything in there, so we need to be careful about that. Also, we have identified logistical challenge, like seawater facilities, seaweed facilities at sea. And of course, where are we going to get source of nitrogen and phosphorus? We need that source in order to apply the circular economy. So basically, we need to use these sources in order to get the NMP and try to reduce the production cost. I am really confident, and we as a team, we are really confident that algae industry will support feed for animal in KSA by 2030. Thank you very much for your attention.